Okay, this is a continuation of section 3.3. In the last video, I had gotten to this example where we were writing the equation of a line. You were asked to write it in both point-slope form as well as slope-intercept form. Each of these has its own formula. So this is the formula for point-slope right here. And I had plugged in for my y sub 1 coordinate, this y coordinate that I was given, there it is right there. I had plugged in for my x sub 1 coordinate, this 10, so this represents x1, this represents y1 in this formula. So I plugged in a 10 right here, which comes after the minus sign. And about the only thing I can do to clean up that answer a little bit is clean up this double negative and report it as a single positive. But when you're giving your answer in point slope form, you're allowed to leave it just like this. You don't need to drag this coefficient through. You don't need to distribute. You can leave it just like this. Okay, that's point slope form. When you go to give it in this form, which is called slope intercept form, and I'll abbreviate that a little bit. Well, in that form, you need to make it look like this. Notice that in this form, y is isolated. There's no parentheses here, and all the other terms are on the other side. All the x terms are on the opposite side that y is on, as well as the y-intercept. So you're going to go from this answer to this answer. So first thing that we're going to do is get rid of the parentheses, and you're going to get rid of those parentheses by distributing. Okay, so I'm going to go negative 3/5 times x, and I'm also going to go negative 3/5 times negative 10 as a way to get rid of these two parentheses. So it's y plus 4 is equal to negative 3/5 times x. There's my x term. And then negative 3x times negative 10, that's negative 3/5 times negative 10. And then you begin to clean that up. So this first term is just negative 3/5 x. And then here it's negative 3 times negative 10. That's 30, positive 30, divided by 5. Again, that's negative 3 times negative 10 is 30. 30 divided by 5 is positive 6. Okay, you're almost there. You almost have the y isolated. Just take this 4 and bring it all the way to the opposite side, at which point it will be negative 4. So your final answer is going to be like this. Y is equal to, you have a negative 3/5 as your coefficient of x, so this is your slope, rise and run. And then when you combine the positive 6 and the negative 4, you have positive 2. This is your b value, your y-intercept, and the slope is this negative 3/5, as I said, where the top is the rise, bottom is the run, just in case you had to graph with it, because oftentimes they'll ask you to go on and graph. So we have our final answer for point slope being this answer right here, where you can leave it with the parentheses. And then our final answer for slope intercept form is where you've isolated the y. So that's a pretty typical problem in section 3.3 where you're asked to give it in two different forms, point slope and slope intercept. Okay, moving on to something that I think will be helpful for you. And so I've given you a couple of problems right here to get you ready for the problems that are going to prompt you into this. Notice that every time I've been giving you a problem, you've had a point that the line has gone through, and you've either had the slope or some way to get a slope. Well, sometimes they don't give you the slope. Sometimes you have to find that yourself, and when you do, you're going to need 2 points. So if you have not been given the slope, you will always be given 2 points that will allow you to find the slope yourself. Points can sometimes be given as x as an x-intercept and a y-intercept. And sometimes students get confused about, well, how do I turn that into a point? So you have to remember what an x-intercept is. It really is a point that gives you two coordinates, which is exactly what you need if you're going to find a slope yourself. So in case they don't just give you 2 points flat out, but instead they call them intercepts, then just be aware of how they can be written, and that's what this is about. So let's use the graph in the previous problem just because it's already there. Let's name the y-intercept. Remember, the y-intercept, any intercept is a point, but when it's called the y-intercept, it's a point on the y-axis. So if we're looking at the picture right above the problem we're working on, the point on the y-axis is called 0, 3, and I just darkened that in for you. So you can list it as 0, 3. If they start talking about the x-intercept, well, then that's a point on the x-axis. Intercept means it touches that axis. So now if we look again at that picture above us, where this hits the x-axis is right at 2. So that point is called 2, 0. You're 2 over, you're 0 up in the air. Whoops, goes right here. Okay, so now if you were going to find the slope, well then you would do what we did earlier in this section. You were given a slope formula, and sometimes instead of them just throwing that slope at you, they make you find it yourself. Okay, go right back to that slope formula. Notice that there's several formulas here, so start working on memorizing them. This is how you find slope. I would suggest that you put the minus in before you start plugging in your x's and y's, just so you'll be more apt at recognizing double negatives should they occur. Now, we don't have any negatives with the points that we're going to be using, so this should be easy. So now you're just going to go one y value minus the other y value. It doesn't matter which y value you start on. Just be consistent in the direction you move in. I'm going to go from this point to this point. That's my chosen direction. So I'm going to be using this as my front y value and this as my back y value. Since I moved from this point to this point, continue doing so when you do the x's. So my front x value is going to be 0, and my back x value is going to be 2. Okay, I got y's on the top, I have x's on the bottom, and I moved from this point to this point both times when I did the y's as well as the x's. You have to move in the same direction both times when you do the y's and the x's, or else you will get the wrong answer for your slope. So 3 take away nothing, 3. 0 take away 2, -2. And that is the slope that you've achieved by being given information regarding the intercepts. Okay, let's move to this next page. And on the next page, the example has to do with a line that passes through 1, -3. We have an intercept of -1. And if you don't want to graph this, you can graph it if you want to. It would just be a point that's on the x-axis at -1. So if you want to, you can draw yourself a picture of it. If you're not understanding whether to put this in the front position or the back position, this number, if you're not sure of where to put the 0, -1 on the x-axis would be right here. That point is also known as -1, 0, where it bears an x and a y coordinate. So that information has to do with this comment. You also have another point that the line passes through, which is 1 and then -3. So right there, this is 1, -3. So anytime you have 2 points, you have a line that goes through it. Two points determine a line, and that line will have a slant on it, and the slant is the slope, how slanted the line is. So if we wanted to figure out what the slope of this line is, which if you're going to write the equation of the line, you have to have the slope. So you need that slope value, regardless of the formula that you use. Okay, so the slope, just keep writing that formula, so hopefully you'll memorize it before you take the test. This is y is on the top, x is on the bottom. My minus signs, I'm going to put those in first. My y values, I think I'm going to move from this point to this point both times when I do the top as well as the bottom. So my y values are 0 and -3. Got a double negative there, so I'll clean it up in the next step. And then my x's, moving from this point to this point, again, -1 is that x coordinate, and then the other x coordinate is +1. -1, +1. The minuses are just from the formula. So cleaning this up, I have slope is 0 plus 3, which is just 3. And on the bottom, I have -1, take away yet another 1, which is -2. Okay, so in this problem, I'm going to be using a slope of -3/2. And then let's see what they're asking. They want, again, the equation of the line in point slope form. So let's write that. Point slope form is this formula right here. Okay, this is called point slope, and that's because you plug in a point and a slope. Okay, so it's y. You only plug in for the y values and x values that have a subscript hanging off of it. So the y sub 1, well, you have this point that you could use if you like, and you also have this point. You can use either one of these. I tend to like points that have zeros in them just because they simplify more easily, but you are welcome to use that one. So that's up to you. I think that what I am going to use, this is what I am choosing. I choose to use -1, 0. Okay, that's my choice, but you may use that point if you want to. Okay, so the y coordinate in this case would be 0 based on the point that I have chosen. The slope, we already discussed that at the top of this page, and then it's x minus the x coordinate from the point that I have chosen. So this would be y is -3/2 times x plus 1. The reason the point that I chose, which was a nice, pretty good choice, is because when you plug into this, you already have the y isolated. So that kind of decreases the work that you're going to have to do in part B. Because in part B, one of the things that you do is you try to get the y by itself. But because I had a 0 here, it's already by itself. So this is what we call point slope form. And then in part B, we're going to do slope intercept form, and that's this formula. Y is equal to mx plus b, and this is slope. Don't have enough room to write this here. Intercept form. All right, so y is equal to, my slope is -3/2. And I'm working right off of this last answer that I got right here. I'm going to notice that again, as I commented in the last problem I did, when you're putting it in slope intercept form, there's no parentheses here. So you can work right off of this one, just get rid of the parentheses. To do that, you just distribute. Just go -3/2 times x, which is the term I'm writing right now, and then go -3/2 times 1. And there you go. You have this equation in slope intercept form. Okay, I gave it in point slope form and slope intercept form. Okay, moving to the next, let's see if I can zero in on this a little bit, make it a little bit bigger. Going to the next problem. we're going to talk about how you write the equation of a horizontal line. All horizontal lines come in this form. Y is equal to, and then whatever the y-intercept is. So if you want to see what that y-intercept is, basically what, the other way you could read this is you just need to isolate y. Notice that there's no x in this equation. When it's a horizontal line, there will be no x. You'll be missing a variable. All you will have is y is equal to some constant, and that constant will be the y-intercept. You can tell that from this one right here. Just isolate the y, just like this equation says, by bringing the 10 over to where the 7 is. You will then have y is equal to 7 combined with negative 10. The 10 is no longer on the left side, it's over on the right. So you have y is equal to negative 3. So this horizontal line goes right through negative 3 on the y-axis. It is a horizontal line that goes right through negative 3. Okay, so all horizontal lines will be written as y is equal to a constant. Okay, moving on to the example to the right of that. I want you to understand that this is just function notation for a horizontal line, which is the example that we just worked here. This means the same thing as y is equal to 5. So we were just discussing what the picture looks like, what the graph looks like when the equation is missing an x, and all it talks about is y. It is a horizontal line. Okay, so horizontal line, there will be no x in the equation. So basically what they're talking to you about is the y-intercept. Just go right through that y-intercept, negative 3, and draw a horizontal line. So every single point on this line has a y value of negative 3. Okay, so if they talk about y is equal to 5, that means that the y-intercept is 5. So that is this picture right here. This is the 0 mark, and here you're up here at 5. I know that's kind of small, that number, but it's just a horizontal line right through the y-intercept called 5. Every single point on this line is up at a height, a y value. Height is y value, a height of 5. Okay, so that is another example of it, just trying to show you one that can be given in function notation where f of x means y. Okay, moving on to the equation of a vertical line. Vertical line will also be missing a variable. Just like this equation was missing the x, when you graph a vertical line, you'll be missing the y. Okay, notice that this is the form of the equation when it is a vertical line. It'll be x equal to the x-intercept. So if you want to graph something like this, you need to isolate the x. Just like in the last example, I isolated the y. I isolated the only variable that was in the equation. You do that by simply bringing the all constants to one side. So this negative 4 will appear as positive 4 on this side, and you will have x is equal to 4 combined with negative 2, which is just 2. That means you are going to find 2 on the x-axis, 1, 2, and draw your vertical line. Every single point on this vertical line has an x-coordinate of 2. Like for instance, if I was to draw a point right here, this point right here that's up in the air 3 units is 2, 3. If I was to plot this point right down here, let's say this one right here, that's 1, 2, 3, 4, 5. You're at negative 5 right here, but still the x-coordinate is 2. So once again, on a vertical line, all the x, any point that you pick will have the same x value. This happens to be the line x is equal to 2. Okay? Notice that there is no y in the equation at all. So the one and only variable that you do have is what you are using to command your picture, your diagram. Okay, moving to the last page. Of linear functions and slope. This next one, I combined all of this, calling it section 3.3. I called it A and B. In your mom software, it may just all be section 3.3, where all of this is, the problems for all of this is in one section. So I am using, some outlines that were from the previous software, but we still cover all the same topics. So in section 3.3, you're going to find everything that I talked about in 3.3a, as well as 3.3b. Okay, so the video I'm shooting now is going to stop at the end of this page because I've already prepared a video for you for 3.3b. Okay, so you will sometimes be asked to rewrite the equation in general form. And here they go, giving you the form of a general form equation. Notice that everything is on one side and it has been zeroed out. There are no fractions in a general form equation. There are no decimals in a general form equation. They're typically, given without these kind of numbers. You're going to get everything on one side, and you can't have both A and B being 0 because then that would wipe out all your variables, and therefore it wouldn't be the equation of a line. So this is the equation of a line, but in general form. Okay, so let's say that we're going to find the equation of the line that passes through this point and has this slope. So we're going to put it in point slope form because that's what we've been asked to do here, as well as general form. So in part A, if I'm using point slope, I have to use this formula. Y minus y1 is equal to slope times x minus x1. Okay, and then start plugging into my point slope formula. I'll do it over here to conserve room. So it's going to be y minus the y coordinate. Remember, that's this back coordinate. And then the x sub 1 that you see in this formula is the front coordinate. So y sub 1 is this negative 5. So it's y minus the y sub 1 coordinate. Got a double negative going on there. The slope is 3/4, positive 3/4. So I just plug that in there. And then the rest of the formula goes x minus the x sub 1 coordinate, which is positive 2. This minus just comes from the equation. Okay, I can clean this up slightly, but basically I can leave it almost like this. I'm just going to clean that up. Point slope can be left with the parenthesis in the answer. Okay, now I'm going to go for part B. And in part B, we're dealing with writing the form of our equation in this new form called general form. Not that it's new because you have seen this in the previous class, and we are reviewing it. Okay, so we're going to get all terms on one side, no fractions, no decimals, no parentheses. Okay, you want to make sure that all of these things are happening when you get it in general form. Okay, so here we go with that. I'm going to go again right off of the last answer that I have. First, I'm going to get rid of the parentheses. So I'm going to carry this 3/4 right through to the x, and I'm going to also distribute it to the negative 2. Right now, I'm going to leave the 5 where it is. So it's y plus 5 is equal to 3/4 times x, which is 3/4 x plus 3/4 times negative 2. Okay, so I will have 3/4 x. This would be, you can reduce right here. Instead of writing it over 2 more times, you could just go 2 goes into 2 once, 2 goes in here twice. I mean, because if you did multiply them, you would get 6 over 4, and then you'd have to reduce it when you can take care of all of that in one shot. Just 2 divides into 2 one time. That's why I have a 1 here. And 2 divides into 4 twice. It'll be 1 times 3. And you do have a negative there. Don't forget that negative. So it's negative 1 times 3. Negative 3 over 2, the reduced number. Okay, you're almost getting there. You're kind of getting there little by little. All I did right now is I got rid of the parentheses. Now again, let's look back at what general form looks like and notice that I have told you all terms should be on one side and there should be no fractions. So it depends, what you want to do. You could get all terms on one side first, or you can get rid of the fractions. I'm going to get rid of the fractions. I got rid of the parentheses first. Okay, so step 1, I rid this of parentheses, and I did that by just distributing. Okay, after I did that, what I'm going to do now, I'm going to have to continue this down here. Step 2, I am going to get rid of the fractions. And the way you get rid of fractions is you just multiply this entire equation, every single term in the equation, by a number that will cancel out whatever the biggest denominator is here. That's called the least common denominator. So you can't multiply this whole thing by 2 because it won't kick out the 4. It has to at least be as big as whatever the bigger denominator is so that it'll knock out that denominator as well. So what we're going to multiply by, our LCD, is 4. Okay, so here we go. All the fractions are going to go away. It's going to be 4 times y, 4y. 4 times 5, 20. 4 times 3/4. 4 times 3/4, just imagine that 4 right in front of here. This would cancel with this, leaving you with 3x on the right-hand side. And then 4 times negative 3 hash, you can just put the 4 right here. You're always placing it in the numerator. I mean, that's what that's supposed to look like, but the equal sign was in the way. So this right here, after the minus sign, would just be 12 divided by 2, which is negative 6. Note that I have no fractions now. Last step. I got rid of the parentheses. I got rid of the fractions. I don't have any decimals, but I am now going to bring all terms on one side. All terms, just like this shows right here. Notice that they have zeroed it out on one side. It's the same thing as saying all terms on one side when you zero it out. Okay, so I am going to bring, you can either bring everything over here. Typically, they like to report the x term as positive, and you can bring everything over here if you'd like. You can bring the 20 over here, and it'll be negative 20. Don't forget to switch the signs. When you move terms from one side to the other, they take on the opposite sign. It's the same thing as subtracting 4y, subtracting 4y, subtracting 20, subtracting 20, so that you have nothing on this side, and you have 3x. Like I said, typically they like to report the x term as a positive, and that's why I chose to move everything over here. Negative 6 combined with negative 20 is negative 26, and you can even flip-flop this. If you flip-flop this answer that you have here right now so that it looks exactly like this with the 0 on the right, nothing is going to change. You can flip-flop this entire thing without anything changing. I'm talking about the signs of anything. So all of this on the left and the 0 on the right, same answer. This and this mean the same thing. Okay, so that is the completion of the previous example where they were asking you to get it in part A in point slope form, and then in part B you were asked to get it in general form. Excuse my dogs, they get a little excited when someone comes home. Okay, so moving on to the next problem, it says, give the general form of the equation of the line. The easiest way to graph the line is by finding the intercepts. The x-intercept is x sub 0, where the line crosses the x-axis, and the y-intercept is 0y, where the line crosses the y-axis. Given the general form of the equation, the easiest way is to, okay, so we are actually just graphing the equation that we just got. Okay, so here's that equation. Let's concentrate on this right here. And what I'm telling you in this verbiage right above the problem is that if you just find the x and the y-intercept, and in case you have forgotten how to find the x and the y-intercept, this is how, right here. What this comment means right here is let y be 0 and you'll be finding the x-intercept. That's actually how you find one. Then you can find the y-intercept, and this is how you find it. Let x be 0 and you'll be finding the y-intercept. So let's go ahead and do that as a way to get this graphed. Because if you do it where you try to isolate the y and use the slope and the y-intercept, you're looking at a lot more work. So that's why I'm suggesting that you find the intercepts. Okay, here we go. We're going to find the x-intercept. When finding the x-intercept, you're going to let the y be 0 and you're going to find the x value. Okay, so this is going to be 3x minus 4. Let the y be 0. That means plug in a 0. Okay, now solve for x. Okay, so this will be negative 4 times 0. This is 0. So right now you're looking at 3x minus 26 is equal to 0. 3x, bring this 26 to the other side, and you have 26 divide by 3, divide by 3. And why don't we just get an approximation for that? Okay, so 26 divided by 3 is approximately 8.7. We'll keep that in mind when we go to graph. And then for the y-intercept, and if you wanted to give an exact value, if you wanted to, let's say you had to feed in an exact value into MyMathLab to stop them from into the MOM software, instead of giving this approximation, you could type in the exact value, which was 26 divided by 3, 0. But for purposes of me showing you where it's at, that's why I approximated it. Okay, when you go to find the y-intercept, do what it says right up here in these sentences here. When looking for the y-intercept, let x be 0 to find the y partner that goes with it. So we're going to let x be 0 this time. So it's the opposite of what you're looking for. When you're looking for the x-intercept, you let the y be 0. When you're looking for the y-intercept, you let the x be 0. Okay, so let me calculate again. Again, I'm going to use this equation, same one that I used when I was looking for the x-intercept. Now I'm going to let the x value be 0. So I'm going to plug in a 0 for x right here, right in here. And then I'm going to go minus 4y minus 26 is equal to 0. This is just 0, so it's gone. So really what you have left on the left-hand side is negative 4y minus 26 equal to 0. Bring this negative 26 to the other side, and you end up with negative 4y is equal to 26, positive 26, because this comes over to the right, appearing as a positive 26, opposite sign that it has now. Then divide off that negative 4 on the left as well as the right, and you will have, okay, let me come down here just a little bit, y, kind of separate this work a little bit, y is equal to 2 goes into the top 13 times, and 2 goes into the bottom twice, and yes, that is negative. So here's one way that you can write this answer. You can write it as exactly as 13 over 2, where you put the negative out front. That's your, whoops, we were finding the y-intercept, I think, yeah. Yeah, so we were finding the y-intercept, so our x was 0, and what we just found was the y coordinate, so that 13 over 2 goes back here. So you can go like that, or you can put 13 divided by 2, negative 13 divided by 2, in your calculator, and that's negative 6.5 if you wanted to have like a decimal approximation. But oftentimes you're feeding in exact values when you're using a software to help you graph. When you're graphing it by hand, it makes more sense to approximate it as a decimal, so you know in between what two numbers you should put your point, as I'm going to do right now. All right, so let's go to x is equal to 8.7, which is a little bit hard to see. Okay, but this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So 8.7 is going to be about right there. Just do the best you can with marking that. And then on my y-axis, I'm going to go to negative 6.5. So that's going to be 1, 2, 3, 4, 5, 6, 7. So right in between there. So basically, you're just going to connect those 2 points. So connect those 2 points, and that's your line. Okay, so when in general form, it's best or easiest to use the y-intercepts. Okay, that takes us all the way to the end of this section. What I've included for you at the bottom of this page is a summary of everything that I have covered thus far in section 3.3. And we are going to continue in the next video with just a discussion of parallel and perpendicular lines and what that means with respect to writing the equation of a line. Okay, these are the things we just covered. Okay, that ends this video.